Sorry, real quick, I realized we didn't finish angle C. So, although we were able to find that angle C's arc was 64 degrees, because it's not a central angle and it's not an inscribed angle, we can't actually use this to find angle C. What we can use is the fact that there's triangles within the circle. So we found that D was 33 degrees. And so angle C is going to be the same measurement on either side of these lines because we have vertical angles. So if I subtract 25 and 33 from both sides, then I'll find my value of C. So like I said, this didn't really help us to find angle C. It just helped us to find actually the next arc. So this wasn't actually helpful for angle C. So for angle C though, we could take 180 minus 25 minus 33, and we get a value of 122 degrees. All right, finishing up number 5. So the next problems we're going to work with are angles outside the circle. However, we will still be using information about the inside of the circle. So angles outside the circle. So we have this diagram, and angles outside the circle are created when the lines extend past the circle, which gives us 2 different arc measurements to work with. So we have arc 1 and we have arc 2. So the equation that we'll use to find this measurement is theta equals half of arc 1 minus arc 2. Okay, now arc 1 will always be your large one, your large arc, and arc 2 will always be your small arc, or the one closer to the angle. So again, it will always be large minus small. Now another way you could say this, not OB, OR, is if theta is half the measurement of arc 1 minus arc 2, then 2 times theta would be just simply the measurement of arc 1 minus arc 2. Okay, so we can use either formula depending on what we need. So let's try number 6. So number 6, we're going to be finding theta, and the information that we have is that this arc is 68 degrees, and this arc is 162 degrees. And so we want to use the first equation. So theta equals half of the large arc, 162, minus the small arc, 68. So half. Then we find the value of that. 162 minus 68 is 94. And half of 94 is 47. So theta equals 47 degrees. Now let's try number 7. Okay, number 7 has 2 different angles, or sorry, 2 different lines that are both outside of the circle. It doesn't actually intercept the circle, although it really does. Okay, the information that we're given for this problem is that the arc from here to here is 250. Okay, then that's all I'm given. But what can I find out about the arc on the inside, even though it's not listed? Well, we know that the whole circle is 360. So if we know this part is 250, then 360 minus 250 leaves me a value with 110. So this arc would have to be 110 in order for this to be a circle. So I had to do a little bit of more information, but then I can proceed with the problem. So theta equals half of 250 minus 110. So 250 minus 110 is 140. and half of 140 is 70 degrees. Okay, let's move on to number 8, finding x. Now the other information we have here is that this is 200 degrees. Doesn't look like it, but for the purposes of this problem, that's 200 degrees, and this is 30 degrees. So since we're trying to find x, it would actually be a little bit easier to use the second formula. Okay, now x is the arc 2 in this situation. It's the smaller arc. So let's go ahead and start our formula. So it'd be 2 times theta. Now which one is theta? Theta is the measurement of the angle. So 2 times 30 equals arc 1, the large arc, 200, minus the small arc, which is x. So 2 times 30 is 60. And then when I subtract the 200, I get a negative 140 equals negative x. Now, is that okay? No. I have to have a positive x. So I'm going to multiply the whole thing by negative 1. So 140 degrees equals x. So the small arc is 140 degrees. Now, I want you to go ahead and try number 9 using the same method as number 8. So the information for this problem is that the small arc, or arc 2, is 48 degrees, and the angle measurement is 32 degrees. Okay, go ahead and try number 9.